Hello everybody, this is lecture 5 of the Introduction to Electrical and Electronic by Mr. Amr Abdulbari. Today we will go further with the circuits to speak about the types of circuits to recover what we have studied before. The circuit is an intentional and complete closed loop but that the electrons come from the source and move through the path, the wire, and provide energy to every load. So the load might be a lighter, might be air conditioner, might be a refrigerator. So anything inside the circuit, this is the load, and we usually have some breaker. This is a breaker box, or the breaker box refer to something that you switch on and off. You use it to control the circuit, and there is the source. Where is the source come from? The battery or the alternative current source. So this is normally the circuit. So the requirement for a circuit is having a source, generator or a battery, a path, wire or a conductor, load, light, motor, etc. Options: you may have control devices, a switch or a thermistor, or protective devices, fuse or breakers, which is break the circuit when there is a very high voltage, for example. So the types of circuits, all the circuits have to follow one of these types. One is series. Series circuits. Series is only one path, so we have only one path to only one path for electrons to flow from the source to the load and return back to the source. Okay. Then there is the parallel series and parallel circuit, and there is series and parallel combination between both of them. In parallel, here you have electrons that flow in a separate or independent paths parallel to each other to get to the loads and then back to the source. Okay, we will get to parallel next lecture. Then we have short circuit. Short circuit, this is intentional. You just like you connect the both sides of the battery directly, or in the box in the your home. If you connect it directly, there is a short circuit, and the fuse will cut off all the electricity from the apartment, for example. So the path is the intentional path allow electron to return back directly to the source without any load, without getting or flow through any load, directly return back. Open circuit, a path have been removed, or a broken circuit, so the circuit can't operate. Like you switch off the switch, or you cut off the wire, so there is no any electrons that flow through these wires. Okay. Now the series circuits, as we speak, the advantage of series circuits is less wire and enhance enhance the costs that you spend to buy and implement your circuit. The disadvantage is if you cut the circuit here or here, you will find that all of them will switch it off. No energy, no load will be in this lamp or this lamp. So this is one of the disadvantages of the series circuits. Okay. In parallel circuit, as we speak, all of them are parallel to each other. Okay, are parallel to each other. So the advantage is only one failure. If we have a failure here, if this is cut from this point, then this light will be off, okay. However, the other one is okay, nothing will happen because the cutoff is in this parallel. All of them is parallel to each other, so the flow will come through this line and go this to this lamp without any problem, okay. The disadvantage, more wire or expenses, because you use here one switch, two, three switches, and you use wiring to connect all of them. So instead of using one wire to connect and one switch to connect all of them, you spend more wires, okay. Short circuit, as we speak about, as you see here, it's like you connect a wire in in the box in your home, and it is potentially dangerous situation because you make a short circuit on for the source of the electricity, okay. Now the open circuit, it is like you cut the circuit here. I intentionally cut the circuit, or you or using the switch, or unintentionally the weather or traffic, the accident, for example, it will make a problem in the electricity in this area, for example. So if there is cut off here or the switch is open, then the electricity will not go through the wire and there is no light, okay. Now, wire name destination. For the wire name, we you have some this is like a standard or something. For the hot wire, there is three wires coming from outside this link. The one wire is any color other than gray, white, or green. This is coming directly from the source, and the other one is returning back after the load. This is the grounded wire, and there is grounding wire which is connected to the ground, okay, or the inclusion of the electrical equipment. This is to dissipate any electric field or electrical leakage, okay. So the characteristics of a series circuit, again, a current is the same in everywhere in the circuit, so it is same in all the electrical components inside the circuit. In the series, we will focus on the series circuits now. The total resistance is equal to the sum of all the individual resistance and loads. The total voltage is equal to the sum of the total IR voltage. IR voltage drops across every individual resistance. Total power is equal to the sum of the total power dissipated by each resistance. So I calculate the IR in each resistance and sum all of them to calculate the total voltage. I calculate the power as we see before in the previous lectures, and then sum all of them to count or to calculate the total power, okay. However, the resistance and the current, you just sum all of them. Here in the resistance, sorry, in the current, it is the same. The current that come from the source, it is the same in every resistance in the series circuits, okay. So the current formula is IT, that's come from the source. It is I1, I2, I3, IK, etc. So the total current is equivalent to the voltage, the total voltage divided by the total resistance. This is the normal Ohm's law, okay. Now the total resistance is to sum all of them. I sum R1 and R2 and I3, R4, and to the end all of them, and this is the total resistance. Or you can use the Ohm's law, VT over IT, the voltage, the total voltage in the this circuit over the total total current, okay. Now the voltage again is your summation. You use summation of the total voltage. However, how I can calculate the voltage in each resistance, you by just calculate, you have the information about the R, the resistance, and you just multiply it by the I. Here you see that I is the same, I. There is no I1, I2, I3, I4, because it's the same across all the components. So you have the value for R1, for example 100, and I, it's for example 1 ampere. So this is 100 voltage, this is 550, 60, and you sum all of them to get the total voltage. And you can use the same here. Total voltage is equal to the I, the total, or the same one, is equal to 1, and R total, which is equal to the summation of all of them. Okay, now there is something called polarities of the resistors. Here you can just say that if the current, the electrons or the current cross flow enters the resistance, then this is the negative side. This is the point at leaves the resistance. This is the positive side. See here, this is the current flow. This is come from positive to negative flow of the source, the batteries, and it's come from outside the minus. So this is the polarities, this is the minus, because the current will get enter to this place. So from this point to this is the minus and this is the positive of the resistance. And again, if we have, this is the symbol for the ground. I connect this point to the ground. Here this is nothing connected to the ground. Here I connected to the ground. So here the voltage is equal to 0. Okay, then and here the same again, but the current flow is the same because all the ground points are connected together, because as we speak before, and I have a one grounded wire which is connected to enclosure, or the you connected to the earth, you and or the frame of the device. So you have a voltage at 0, but there is a current come across. Okay, so at the point that the current go leave the resistance, it is here, this is the resistance, this is the point that the current leave the resistance, it is the positive side. Okay, this is very easy. Now we get an example of all of what we have now. We have the circuit that we see it here, a simple circuit, and we have the value for each resistance, and we have the value for the total voltage. He asks you to solve for the total resistance and the I, the current that come across all this circuit, and find the individual resistance voltage drop. What is the voltage across this resistance? What is the voltage across this resistance? What is the voltage across this resistance? Okay, so first you just use the previous equation, very easy. As I said before, the total resistance in the circuit is, because it's series connection, you will just summation all of them. 10 plus 20 plus 30, it is 60. Now solve for the current. What is the total current? I is equal to the voltage, total voltage, which is here 12, and divided by the R total, which is 60. Okay, so 12 over 60, it is 200 milliampere. Okay, now we can solve for the individual. What is the for each one? I just learn you that the current on all this circuit, it is the same current. Yes, so we will use this one multiplied by each value of the resistance to get the voltage here. What is the voltage across this component? What is the voltage across this resistance? Okay, so I, the same I, multiplied by R1, which is 10, it is 2. Yeah, the same idea. 200 milliampere multiplied by 20, it is 4. Multiplied by 30, it is 6. You see that the voltage, it is for R1, it is lower, or for V2 it is higher than V1, okay, and V3 it is higher. You see, this is because we add the R, or the value of the resistance higher, go up, then our voltage, it is go up. So the value for R, it is go up from 10 to 20 or whatever. So the value for R, for voltage, it is go up. Okay, so the higher value of resistance, the highest value of resistance in the circuit gets the highest value of voltage. You see that the lowest one, it is getting the lowest portion, or the sharing, if they share the total voltage. If you sum all of them, 2 plus 4 plus 6, you have to get 12. You have to get the total. Okay, if you have something else, then there is something wrong with your calculation. Okay, but where is the most of the voltage go? It is going to the highest value of ohm of the resistance. Okay, so the total power, as we see before, what is it, how we calculate the power? You calculate the power using the V multiplied by R, or you just remove one of them and use ohm law to calculate the others. Okay, so the total power across the series circuit, again the series circuit, don't forget that, it is, you just sum all of them, b1, b2, b3, b4, bk, whatever. So, or you just calculate the voltage, the total voltage multiplied by the I, the current that come across all the components in this circuit. Okay, now there is something called aiding and opposing voltage series circuit. Now we speak about the polarities of the resistance. Yes. Now we have something that called polarities for the voltage sources, for the battery or whatever it is, a generator or something. But we use this symbol. You see here that we use one line. Sorry. So you see here we have one line, we have a small line. The bigger line, it is equivalent to the positive side. The smaller line, it is equivalent to the minus side. Okay, this is this this is the source. Okay, the symbol for the source. So the symbol for the source, if it is from this side, it is minus. Yeah, let's see in A. It is from this side is minus, this side is positive. If we have the same arrangement, so minus positive, then you will sum all of them. 6 plus 8, it is 14. Okay, if you have, for example, here minus positive, then I have 6 voltage supply to this circuit, but I have the opposite side, I have positive and minus. Then I will subtract both of them. It is like you have a current come from this side, and I have a current come from this side again. So both of them is leaking, both of them, you have just like not helping or not aiding. Okay, so the polarities is important in the circuits. So because here, because both of them at the same polarities, we have a total voltage of 14. Because here the opposite, we have a total voltage of 2, which is very low, because the current here, it is 1. See, because you just divide the total voltage by the total current, 2 over 2, it is 1. But the same circuit, the same resistance, divide 14 by 2, it is the current we have 7 ampere. Okay, so this is another information to remember, and it will help you to learn about the polarities of both the resistance and the voltage. Okay, of course the voltage, the polarities is fixed. So if you use a battery, for example, you will see that there is plus and minus signs in the battery. You can't change these polarities in the because this is an active device, but the resistance, it is passive. It takes the current from where it is go through it, so it doesn't matter. Okay, so we just learned before that the place where the current goes through the resistance, the point that it is entered, it is minus. From where it is leave, it is plus. If it is come from this side, it is minus positive. So it is the polarities of the resistance change according to the flow of the current. Okay, now we have some information about the open circuit. Open circuit, if you remember, you just have a circuit and you have a cut inside the circuit. So the circuit is connecting like this, and you have something, a problem, like you have a cut in this circuit, so there is no connection here. So if this is open, no current flow. When a circuit is open, the applied voltage, we can see the voltage here, V1 and V2. So the total voltage is, to see the total voltage here again, V T as V1 minus V2, but we don't see current. The current is 0, but we see a voltage. If you take a multimeter and you measure the voltage, you will see there is some voltage, but you can't see the current because there is no connection. Okay, this is the end of the today lecture. I will give you some assignment and example to solve and to learn more about the series circuit. Thank you for listening.